real-world project, designing a secure in-house chatbot system, Milestone 4. This project demonstrates the feasibility of a secure in-house retrieval augmented generation chatbot designed to support small business development center advisors. The Small Business Development Center is a federally funded nonprofit organization providing no-cost advising services to entrepreneurs across all U.S. states and territories. Its mission is to support economic development and job creation by helping individuals start and grow small businesses. Entrepreneurs frequently struggle to understand the requirements for choosing a business entity, acquiring licenses, or registering their company with local authorities. Complicating matters, there's persistent misinformation about online about LLCs, corporations, taxes, permits, etc. To address these challenges, our engineering team developed a secure self-hosted RAG chatbot intended to augment SBDC's advising services. The chatbot answers frequently asked questions, provides region-specific business formation guidance, and dramatically improves client response times while still preserving a strict data policy. A typical interaction goes along the lines of a user asking what license, entering in a query, asking the chatbot what license it needs, what sort of things it needs in order to get its business started. The chatbot will then retrieve relevant federal, Washington State, King County, and Seattle municipal regulations, assuming that the question is based in Seattle, using RAG, and produce a structured answer with links. Our prototype focuses on two regions, Washington State and the Los Angeles region. The self-hosted RAG chatbot is designed to operate entirely within a local environment, ensuring that no data is transmitted to external services. All core components, including the language model, vector store, embedding pipeline, and retrieval chain, run on the user's own machine behind a local network firewall. This architecture supports strict data privacy requirements and guarantees that sensitive information never leaves the contained environment. At the center of the RAG pipeline, at the center of the system, is the RAG pipeline, which orchestrates retrieval and generation. When a user submits a query through the chat interface, the query is first routed to the RAG pipeline. The pipeline retrieves relevant vector embeddings from ChromaDB, applies guardrails and the prompt template, and then forwards the enriched prompt to the locally hosted OLLAMA LLM and Mistral 7b runtime. Ollama generates the model's response to entirely on the device, and the output is returned at the RAG pipeline before being delivered back to the user. Supporting this workflow is the document ingestion pipeline, which is responsible for pre-processing the reference materials used by the system. Documents are loaded, split into chunks, converted into embeddings, and stored within ChromaDB, which persists all vectors locally on disk. ChromaDB never communicates with external databases or services, and retrieval operations occur strictly within the secure boundary. Security is enforced through a local containment boundary, which ensures that all computation, storage, and retrieval remain isolated from the internet. This includes the LLM runtime, the vector store, and the RAG components. The system does not use any cloud APIs, remote inference endpoints, or external databases. All interactions occur strictly on the user's machine, ensuring full data ownership, privacy, and compliance internally with confidentiality standards. Now we'll go through the steps and show the prototype. This is a command line proof of concept and not yet a web application. So I need to run all the steps directly in my terminal and command prompt in order to demonstrate results. This requires an Ollama server to be running on a dedicated terminal using the Ollama serve command. The prototype also requires that the user run the ingestion script, a process which loads the training data into the Chroma vector database. Once that's done, I can run the chat handler in the command terminal, which I shall now do. Excuse me, I need a new terminal for that. Excuse me, I forgot to switch directories there. So we ran the chat handler. And it's starting the proof of concept demonstration. It's just being a little nervous today, I guess. The console output is going to show two distinct interactions. The first, as you can see, a query similar to the one I used in my initial example. Um, and that is an in-context query, which the RAG successfully responds to based on the fact that it has that data. The second query, what is the capital of France, is an out-of-context query, and the model should refuse to answer a general knowledge question because the answer is not within the knowledge database, showing guardrail success, and all the interactions are logged in a file called toConversation, or sorry, conversation log.txt. And there you have it. Excuse me just a moment. So now that you've seen a demonstration of the prototype, here are some of the next steps. On the front end, this looks like a simple, secure web application that's accessible through the organization's intranet with key features that include document upload page, SEO for local accounts, and clear privacy and usage notices, amongst other things. And all this should be done, of course, HTTPS. On the back end, this would look like a framework such as Fast API or Node.js. And things like this would handle user authentication, security management, sending user queries to the RAG pipeline, returning responses to the browser, logging, auditing, and data validation, controlled document ingestion, and access level enforcement. And it should be ensured that the backend endpoints are never exposed outside of the organization as well. The RAG engine and model would run a dedicated internal server workstation, and ChromaDB would persist in service mode. All models would be local, ensuring that no data leaves the organization's network. On the storage layer, this would look like ChromaDB's persistent vector database, a document repository with version control, and an optional SQL database for credentials, access logs, and metadata. Data would be encrypted at rest and access controlled as well. The user access path would also be a next step, involving an internal web application hosted on a private network or campus server, advisors logging in with institutional credentials, and an LLM and vector data that never leave the building. This ensures the tool is accessible to non-technical users. That ensures it. The lesson learned from this project and some challenges faced. To address that, we learned that having 3 people run instances of a Python terminal-based prototype, even in a virtual environment, introduced challenges with regard to package management. One solution was to start over fresh. In the case of this example with a Anaconda environment, using Python 3.11 instead of 3.12. Even though theoretically ChromaDB's website says it runs on Python 3.12, this fixed our issue amongst many, but a lot of it just had to do with the package management, and even especially a lot of the technology is new and constantly updating. So being on the same page about that was very important, and it was very nice to have a requirements.txt file. Running the installation of all packages from a single file like that, though, did pose other problems, because what we ran into was that if one of the packages failed, all of them would fail, and you had to abort and start over from the beginning. Further future ideas for this project involve expanding to additional regions, support for different categories, improved UI UX, and multi-language support. In conclusion, this project demonstrated that a secure, locally hosted RAG chatbot is a feasible and highly beneficial tool. And by combining specified data on a self-hosted LLM with comprehensive privacy protections, significant challenges can be addressed. Thank you.